So that how we can run the regression model. Simple. The qualitative variables are called, for example, if you take gender, so gender may impact on the production. For example, if you take the production is depends on mainly two factors. Okay, so generally labor and capital. For example, if you want to take any industry production, for example, so in the industrial there are people, the labors may work, the labors may be two categories, for example, male and female. So for example, the male people may work more than female, or female people may work more than males. For example, the gender is a qualitative variable. So how the gender can impact on the production of the some goods. So the gender, if you take gender as a independent variable in regression, so how you can run a regression model in the in econometrics. Then we will discuss, so what is meant by qualitative variables. So that qualitative variables are called, we can say in econometrics terminology, dummy variables. Simple, dummy variables. So that is called a regression with a dummy variables. Regression with a dummy variable. And what are the use of dummy variables. So we'll discuss one by one. This is not work. If it is visible.
Yes, sir.
So here, simple, the main important question will also come. What is meant by dummy variable? For example, if you have the 2 months question or 5 months question, so definitely the question will come. What is meant by dummy variable? So dummy variable is nothing but simple. Dummy variable is nothing but qualitative variables. Qualitative variable. So what is qualitative variables? For example, we cannot quantify the value of the particular variable. That is called qualitative variable. What is quantitative variable? We can measure it, but qualitative variable we cannot measure easily. So for example, do you think that the male is greater than female, or female is greater than male? So it nothing but the gender, nothing but male has its own characteristics and female has its own characteristics. But we cannot say that the man is greater than woman, woman is greater than men. Or else, if I want the other example, for example, colors, black and white. For example, if you take the black is better than white, or white is better than black, can you say that?
So no.
So it has its own characteristics. Nothing but, so each color it has its own characteristic, but it cannot compare with the others. Nothing but these are called qualitative called. So this is called qualitative variables, the dummy variables. So then I will discuss one by one. So the qualitative variables will not provide answer to all the questions. So if whatever I'm going to ask the question, see, already asked the two questions, that is black is not greater than white. For example, do we think that black is greater than white or white is greater than black? So we cannot get a suitable answer. Nothing but if I say that black is greater than white, somebody will ask the how. For example, if I'm not agree with the black is greater than white, so it means that white is greater than black. So the question will not give the proper answer to all the public, or all the question, all the answer may not give the all the questions. That is, the variable will not provide answer to all the questions. Incorporation of qualitative variable is needed for the realistic analysis. For example, see, we need incorporation of qualitative variable is needed for the realistic analysis. For example, if you take gender, that is a male or female, season. So would you like to say winter season is better than the summer season? Summer season better than winter season?
No, sir.
No. For example, caste, the OC is better than SCs, or SC is better than BCs, or BC is better than EBCs. We cannot say. So each has its own characteristics, nothing but, so it does not have the any circumstances, we can say. Religions, we cannot say that Hindus are better than Muslims or Muslims are better than Hindus. Region, for example, if you take South Telangana, North Telangana, or South, North, East, West in our states, for example, and policy changes, for example. So can you identify that before implementation of some GST or some other bills or if you take LPG. So here the policy also it has a qualitative variable only. Policy has a qualitative variable. It is not a quantitative variables. We cannot measure that impact of policy. For example, see, if you take into account, nowadays the government has taken a 3 bills which are related to agriculture. So this policy, nothing but is one of the policy which has framed by the government. On the base of the policy only, they framed the 3 acts. So it is nothing but it is one of the policy. And environmental changes. For example, if you take before lockdown, after lockdown, or some environmental changes, and war also. For example, if you take India, 1948 and 56, some other wars, and peace, control and decontrol. For example, if you take controls, what is absent and presence? For example, see, if you take into account, nowadays we have been facing a lot of problem for the which is corona diseases. See, in order to improve the medicine for the corona, so they have taken some sample of people, and they are nothing but they are giving some medicines to the people. Nothing but some of the controlled people and some of the uncontrolled people. So here they are giving some medicines to some people, and they will check whether the medicine is working properly or not. So there is a control and uncontrolled or decontrol methods. So this is called qualitative variables. Qualitative variables. I think I hope you understood what is in my dummy variable, and dummy variable is also called qualitative variables. Have you understood?
Okay, sir.
Simple. Some of the question will come from that net and set also. That dummy variables are also known as qualitative variables, or qualitative variables
Okay.
also known as dummy variables. And if you take that quantitative variables, for example, if you take age, so we can measure in terms of years or months or days. If you take education, we can measure one first year, second year, third year, like this, for first class, second class, third class. This is the quantitative variable. For example, if you take production, exports, GDP, exchange rate, these are the called quantitative variables which we can quantify the variables value. And this is one of the important question. That's the dummy variables which takes only 2 values. There is a 0 and 1. Dummy variables values only 0 and 1. Simple, you can remember dummy variables value 0 and 1. 0 means absence, 1 means presence. For example, if you take gender. So for example, gender means 1 for male, 0 for female. For example, I'm saying 1 for male, 0 for female. So if you put 1, it means that male only. Nothing but if you take the female male data, so you can put gender in the instead of male, you can put 1. It means that the male presence. 0 means absence of female. So here 0 indicates absence, and 1 indicates presence. For example, I may give another example. For if you take impact of LPG on Indian GDP. Okay, so impact of LPG, nothing. What is LPG? Liberalization, privatization, globalization. As you know that, so which is introduced in the 1991, right? So, for example, if you want to know that whether the LPG policies impact on Indian economy or not, how you can take dummy variables? So, dummy variable nothing but is a policy, that is a LPG. For example, if you want to take data from 1970 to 2020 data, so from 1970 to 2020, if you take 50 years data, so up to 1972 2000 sorry, 1970 to 1991, so we can put 0, nothing but there is no policy, that is called 0 means absence of the policy. If you take 1, that is the presence of the policy. From 1991 you need to put 1, so that is called presence of LPG. Have you understood, or shall I show with
Okay, sir. Okay.
so for example, if you don't mind, then I just give me. So I will show you that, don't worry, that I think it is visible. This Excel sheet.
Okay, sir.
See, for example, this is a GDP data, for example. Okay, so this is the exports. Okay, so here you need to know that LPG. Okay, so for example, this is a GDP data, for example, something I am writing. For example, like this. For example, if you take this a dummy variable only, dummy variable. So exports value, for example, if you take so this is a dummy. For example, here, if you take here, sorry, here I going to take years. For example, 1971, 1972, so 1973. So like this, if you take year 1991, for example. 1971, for example, your exports value is 1992. So here, if you take this value, so here it shows the C. For example, up to now, you should take 2020. For example, you should take the data. Okay. See how you can take this data. See, this is a dummy variable. So here is a 1991 is nothing but is a absence. Okay, so you can put 0. So then from 1991 you can put 1. It means that so here the policy is absent from this 1991. The policy is present. Okay, so like this you can put 0s and 1 for the dummy variables. So I would next I will say that I will show you in the PPT also. The dummy variable technique, a technique which incorporate qualitative variables into analyze using the dummy variables. See, for example, if you take, if you write an equation, the expenditure on clothing. See, as you know that how much expenditure on the clothing. For example, it is nothing but whatever we have taken that example, that is Engel's law. See, y is equal to a plus bx plus u. That is a normal period. For example, as you know that y is nothing but here per capita expenditure on cloth. Nothing but expenditure on cloth is depends on intercept. That is a is equal to intercept, b is equal to slope of x. What is x here? Income. Nothing but the consumption is depends on income. The expenditure is nothing but consumption. Only we have taken the expenditure on cloth only. This depends on the our income plus u. There is a normal period. Nothing but the expenditure depends on the income. Then during the festival period, the expenditure cloth increases. See, as you know that when you for example, as for the Hindu religion, so some other religions, so during the festival season, what will happen? The expenditure on cloth will be increases. So generally here also during the festival period, the expenditure clothing increases. So what you can assume that the households increases why there is income increases by fixed amount of A1. Nothing but so during the festival, so their income increases by a certain amount. That is a A1. So that we are added here. Y is equal A plus A1 plus bx plus u. That is a is intercept. This A1 is nothing but the incremental income plus b of x. That is a bx slope of x plus u is nothing but error term. This is during the festival period. So generally, as you know that when you draw your consumption income levels, see as you take your income, your consumption here. So as your income increases, the consumption level also increases. So this is a normal period. During the festival period, there is some gap between these things. For example, when you are for example, if you take your expenditure, normal expenditure also, during the festival season, your expenditure may increases because you need to spend a lot of amount for that clothes, some home work, for example, home foods or mutton, chicken biryani or dawat. For example, if you take alcohol, other things, we need to spend a lot of amount for the festivals. So certain periods during the normal periods, during the festival period, the expenditure may be expenditure will be increases compared to the normal period. For example, if you take into account, if you club two equations, the first and second equation, what will happen? Y is equal to a plus a1 d. There is a dummy. There is nothing but the presence and absence of the festival plus bx plus u. So if you take where d is equal to 0, that is called dummy. There is a normal period, nothing but there is no festival. One is nothing but festival period. 0 nothing but absent, nothing but absent in the sense if there is no festival during the particular period, so that is called 0. If there is a festival, it will indicate with the 1. That is a presence and absence, nothing but presence in the sense if the festival is there, that is called presence. If the festival is not there, it is called absence. So if you take this one, d is equal to 0 and d is equal to 1, as I told you that in the just now only, there's a Excel sheet, absence and presence. Absence is nothing but when there is no policy, when there is no festival. If there is a festival, you can put 1. So how we can know that, how we can take the decision? There is estimate the parameters by OLS method. There's the ordinary least square method. So how we can estimate the parameter? That is called C. There's a slope value, and we can take the decision whether the significant or insignificant of the coefficient of dummy variables. There is a significant or coefficient of dummy variable imply that two functions are different. See, if you take the slope shift, for example, with only b and b plus b1, nothing but b1 only if you take the b value. That's the first normal equation. If you take this one, the festival mode season, festival equation, y is equal to a plus bx plus b1, or we can, as we know that a plus a1, like this, bx plus u. So yeah, this is the slope of only b, nothing but normal period. If you take festival period, the slope will be high. So as you know that if you the income increases from this much, how much in consumption changes? So if you take a festival, if income increases from year to year, how much consumption changes on the graph? I think I hope understood by looking at the graph. The slope value. Hello?
చెప్పండి సార్.
అర్థమైందమ్మా?
యా సార్.
See, this is the normal period slope. This is the festival period slope. Nothing but if income increases something, how much consumption changes? Nothing but see, due to income changes, how much consumption changes due to the normal period. So if income changes, how much it can leads to increase the consumption? This is the festival season. So generally, as you know that if income increases, the consumption may changes during the normal period. But if you take in the festival period, so if income increases, how much your consumption changes? So this is the y is equal to a plus bx plus b1 x1 plus u. That is error term, as you know the u, that is for the festival period. So if you take into account, or else if you club these two things, so there is a y is equal to a plus b plus b1. This we can add this b slope of this one and this one. See, if you take this is b1 and this is a b1, this is only b, this is a b1. So this is a b plus b1 is nothing but during the festival period, b plus b1 slope. This b amount and b plus amount, a slope value. That is the fourth equation. See, equation 1 to equation 4, there is a can be club. For example, if you take first equation, second equation, fourth equation, so you can take that y is equal to a plus bx plus b1 dx plus u. So the normal bx is the slope of income plus b1 is the d of x, nothing but is the dummy variables slope value. That is the fifth equation. So as you know that d is nothing but if d is equal to 0, the normal period, d is 1 to 1, that is the festival period. So the fifth equation reduced to the equation 1 when d is equal to 0. Then it reduces the equation to 4 when d is equal to 1. So it doesn't matter. This is, you can take this one only. Then after taking that, we can estimate the OLS method. See, as I explained just now. So if you take that as per psychological consumption function, so as income increases, the consumption also increases. See, so this is a 45. It is not 45. See here. So there is an intercept from here to here 0, here some values, nothing but if income is 0, there should be some consumption. So then after income increases, the consumption level also increases. So how much changes in income? How much changes in consumption? Nothing but delta C by delta Y. So C by Y, APC and MPC. So at the same time here, if you don't have any income during the festival period, you should have to spend some money for that festival. So you need to purchase the clothes for your children or your friends or father something. So you need to spend a lot of money for the festival. So as your income increases, the consumption for the festival also increases. See, if you take that household increases y by a fixed amount, there is a1, so plus fraction of the their income. See, this is the a1 a plus this one. So that is the y is equal to a plus bx plus u. That is the normal period. So then y is equal to a plus a1 plus bx1 plus b1x plus u. That is the festival period. So if you club this first and sixth equation, so that is you can get y is equal to a plus a1 d, that is the dummy value, plus b1 plus b, sorry, b plus b1, that is called slope of this normal period plus slope of festival period. So we should have, and we should compare that impact of dummy, nothing but impact of festivals on the expenditure of cloth. That is the final y is equal to a plus a1 d plus b plus b1 into x plus b. Are you understood about the dummy variable, how we can do multiple regression? హలో, అర్థమైందా? హలో, ఉన్నారా? Are you there?
Yes, sir.
Then we need to understand when we have the multiple regression, how we can use the dummies. So see, for example, there is a normal festival and rural. For example, if you take, as we taken that two dummy variables in the multiple regression. So just now we have taken that normal period, that is a festival expenditure on cloth during the festival period and normal period. And so the expenditure depends on the rural and urban. For example, rural people expenditure is different from the urban people. So the rural and urban also called dummy. So we cannot say rural is better than urban, urban is better than rural. See, y is equal to a plus a1 d1. There is a dummy one for this one, normal and festival, plus a2 plus d2. That is called rural and urban, dummy 2. d2 nothing but dummy variable 2 plus bx plus u. So as you know that the d1, that is the d1 is equal to normal period 0, d2 is nothing but festival period. So d1 is not d1 1 is the festival period. d2, if you take d2 is equal to 0 rural, d1 is urban. So don't confuse that. You can put 1 here also here, 0 also here, normal and, but you need to be careful that what is 0 and what is 1. For example, why should we give 0 for rural? Why should we not give? Why should not give to the urban? So there is no rule and thumb rule, but you can give the d2 0 nothing but urban, d2 1 is nothing but rural. Doesn't matter, but you should be careful that before giving that dummy variables values, you should be careful that, so because when you are going to interpret the values, you may be confused. So in that case only you should be right on your some on the book or in your book. Not only intercept differ from rural urban. See here, so whatever the intercept is there, so it should be differ from rural and urban. And shift in intercept during the festival period is same for the rural and urban. For example, whatever shift from festival period is the same for rural and urban. Nothing but in the rural people also and urban people also during the festival season. So the shift will be same, because in the rural people also they should have to purchase the clothes, and the urban people also they should have to purchase the cloth during the festival period. Am I right?
Yes, sir.
Yeah, but only intercept different from that rural and urban. For example, if you take whatever the different intercept is there, the basic intercept, that is from 0 to a1. See, from here to here, it should be same. So it is different from the rural and urban, because for example, if you take this a rural, so for example, it may be high for the urban areas, but this shift will be more or less same, because rural people also they may increase their expenditure on the cloth during the festival season, and urban people also they may be increase their expenditure on the cloth. So another thing, so I will explain later this, because linear probability model is another model. So this is also very important. Then I will explain later. In just a minute, I will explain that what is the use of dummy variable also.
Unbuttoned, sir.
Yeah, now. So as I told you, the dummy variable usually indicate the presence and absence. So that is a quality or an attributes. So such as male or female, white and black, white or black. For example, if you take a democratic and non-democratic, you can say that republic. So these variables are essentially nominal scale variables. Generally in statistics or research, we can use there is a nominal scale variables, So one way we could quantify such attributes, for example, if you take this black and white, so nominally we can quantify nothing, but we could quantify such attributes is by constructing artificial variables. It takes values of 1 and 1 or 0. So as I told you that one is indicates the presence of the attributes or presence of the variable or presence of the policy. 0 nothing but options of the policy. So you may give like this also, male is equal to 1 or female is equal to 0, nothing but here female is equal to 1, male is equal to 0. So you may give it to the two way, but if you give like this only, you should be careful that so 1 is given for the male and 0 is given for the female. So if you take even though education, for example, if you take some of the samples from the farmers, if you take educated or illiterate, for example, if the person is illiterate, nothing but if the person is educated, we can give the 1, and illiterate, we can give 0. So within the education, first to second class, third class, it may be quantitative variable. But if you take that whether the person is educated or not, if the person is educated, yes. If the person is not educated, no. For example, that is the case. If the person is educated, we can use 1. If the person is not educated, nothing but illiterate people, we can indicate 0. Nothing but absence of the knowledge or absence of the educated. Or if you take that pre-liberalization, post-liberalization, if you take the LPG, for example, before and after. So all the dummy variables are designated by the letter D. So as I told you that just now also in the regression. So yeah, B1D. There's a B nothing but D is nothing but dummy variable. Okay, that variable that assume such as the 0 and 1. The D is equal to 0 and 1. So that is the dummy is equal to 0 nothing but there is a absence of the policy. Option or pre-liberalization. If you put D1, that is called post-liberalization, nothing but after liberalization. So dummy variables can be incorporated in the regression model just as easily quantify the variables as I told you that. So in the regression analysis, the explain variable, that is called, we can say the explanatory variable or independent variables are qualitative in the nature. So generally, if you take, even though we have the two types of qualitative variables, One side we may take as an independent side, we can take the qualitative variable. So if you take the qualitative variable that depends also, we can do the regression. So that regression is called another one, and this regression is another one. So regression with the qualitative regression analysis with the independent qualitative variables. So if you take independent variable as a qualitative variable, the model is different. So if you take dependent variable as a qualitative variable is different. So today we will discuss about only that independent variables are qualitative in the nature. So that kind of variable we cannot measure, capture data with regard to the particular variables. For example, gender, color, race, policy. For example, such kind of variables we could not find out, and we cannot capture the data with regard to the particular variables such as gender. So see, male and female. Would you like to give the male is more than female? So we cannot give. Color is black and white. Black is greater than white, or white is greater than black. We cannot give the race and policy also. For example, if you take the people before policy, after policy, we cannot give. For example, if you take any policy, one policy is better than another policy, we cannot give. So each policy it has own its characteristics. So for the sake of this kind of qualitative variables, we can give or assign that dummy variables values, that is a 0 and 1 in the normal conditions. For example, if you take that, as I told you, that impact of gender and production of goods. So as I told you, for example, here, see, so here impact of some policy on GDP. So here dummy variable is nothing but one of the independent variable. So we can write GDP nothing but y. Y is equal to a plus b1 x1 plus b2 x2 d. Sorry, instead of x2 we can write d. So like this we can write. See, I am going to write y is equal beta 1 plus beta 2 exports. That is, we can say that in terms of x plus beta 3 d plus u. So this is a regression model. See, y is the GDP is the function of, or is equal to b1 is nothing but constant value or intercept value, plus beta 2 is the slope of exports, and beta 3 nothing but slope of dummy variables value, whether the particular dummy is impact on GDP or not. Nothing but, so is the impact of liberalization on GDP or not, we can take into account. So we can write like this equation. And impact of LPG on exports as we have taken. So impact of education status on agriculture production. For example, if you take production levels of the in agriculture field. For example, when you observe in villages, what you can observe, see, those who are educated, they can produce more production compared with the illiterate people. Sometimes illiterate people also they can produce more than educated people also. We can compare that whether the educated people are producing more or nothing but either education is impact on the agriculture production or not. We can observe also. And impact of number of study hours on score of marks of the students. For example, if you take, so impact of number of hours. For example, if you study 8 hours per day, for example, how much you score it. So if you are not spend 8 hours, how much you got the marks? For example, absence and present, nothing but if you study less than 8 hours, you may treat as a 0. If you study more than 8 hours, it may treat it as a 1. Nothing but is the impact of study hours. Nothing but is the study hours in the sense 8 hours, for example, or 5 hours you can say. So if you study daily 5 hours, you may treat as a 1. That is called, if this 5 hours can impact on our marks or not. So such kind of things only we will do by using that, or else sometimes it may be treated as a quantitative variable. So the number of hours. For example, if you take 1 hour, second hour, third hour, it will take as a quantitative variables, but it will not as a qualitative variables. So we can convert the quantitative variable in the qualitative variable also. So as I told you that in the regression model with dummy variable C, yt is equal to beta 0 plus beta 1 x1 plus beta 2 x2 plus u. These are normal regression model. See, after introduction of dummy variable, how you can write it? Yt is equal to beta 0 plus beta 1 x1 plus beta 2 d. So as I told you that a dummy variable indicates the d. D is but dummy variable. For example, if you take whatever you are going to take, as I told you that in the dummy LPG, you can say d. So in a multiple regression model, consider the previously exact that instead of quantitative variable regression, we have only one dummy variable that taking the values 1 and 0. So same thing. So if you take this multiple regression, and here we should have to take that dummy variable. Instead of taking another variable value, we should have to take the dummy values, presence and options. See, for example, one is for the presence of post LPG, 0 is for absence of LPG. So as I told you that reforms. For example, you should have to take years, exports and dummy. For example, if you want to know that whether the impact of LPG on exports or not. For example, after liberalization of privatization and globalization policy, whether this policy is impact on our Indian exports or not. So see after 1991, see 1982 to 1991. So I should indicate 0. These are dummy variables. So from 1991, so that export value is a dummy variable, nothing but presence 1. Now one is nothing but presence of the policy. 0 is nothing but options of the policy. So we should have to take like this data. Are you clear? Do you have any doubt? Hello? Saraswati,
Clear,
Saikiran,
sir.
other people? Manasa?
Clear, sir. Clear, sir.
Manasa, Durga, Manoj, Monica, Srikant, Jigandi.
Okay, sir. Clear, sir.
Mita Lundra, sleep mode.
Okay, sir.
Vintunam, sir.
Okay, see, for example, if you take the presence and absence of model, see, so if you put P into 1, that is called a presence, B into 0 is equal to options. So we should write like this also, yt is equal to beta 0 plus beta 1, 1 ut. So yt is equal to beta 1 plus b1. So it multiply with 1 only, it comes only beta 1. That is a vt, that is a random error. But here, if you take into account, if you multiply the beta 1 into 0, something you will multiply with 0, that is equal to 0. That is the yt is equal to beta 0, nothing but it is an intercept value only. Am I right? Have you understood this point? Nice, very.
Okay, sir. అర్థమవుతుంది.
0 nothing but options. For example, if you multiply with beta 1 0, nothing but you will get 0 only. It means that, so here beta 0 plus beta 1 into 0 plus ut, that is a beta 1 0 plus beta 1 into 0 0. So if you add 0, nothing will be happen, nothing but that's why I put it only beta 0 plus ut. So it seems that whatever I give an example, that is slope values. So that is a presence and absence. The presence from the, for example, if you observe from here, I think I have, see here, here this is a normal period, nothing but here the dummy the intercept value is here only. For example, for that festival period or normal period, the festival period will be high because it will add from normal period to festival period. That is a beta 1 into 0 0. So here for the impact of dummy only, for the in order to know that whether the festival is impact on the expenditure cloth or not. So this is this much from this curve to this one. So there is an impact of festival on expenditure on cloth. I hope you understood this one equation very easily. And if the dummy variables are also called binary variables. So as we know that if the dummy variables are 2, that is called binary variables. Binary nothing but 2, as you know that. Okay. So there is a dummy variables values takes 1 and 0 only. Okay. Dummy variables are called binary variables. And dummy variables are constructed by the econometricians to be mainly used as a proxies. For example, why we can take the 0 and 1, then is nothing but proxy for other variables which cannot be measured in any particular case for various reasons. For example, as we know that in order to know that whether the particular variable is more or less, so we can give only proxy. So that is a male, 1 for male or 0 for female. Only that is a proxy. I hope you understood what is meant by dummy variable, how we can use in regression model. So if you understood only, then I will tell you that what is the use of dummy variables. So which is very important question for that annual examination.
Okay, sir.
The first use nothing but here the use of dummy variable. The first use is nothing but here see dummy variables as a proxies to the qualitative variables or categorical variables. So what is the categorical variables? For example, if you take profession, religion, sex, region, and rural, urban. For example, if you take gender, male or female, for the sex, and region, for example, south, north, east, west, rural and urban. Professions, for example, if you take the teacher, professor, lecturer. So these are the dummy variables values, categorical variables. We can see the proxy variables. And dummy variables as a proxy to the numerical factors, that is the quantitative factors. For example, if you take the exports, pre and post. For example, pre-exports and post-exports. And education status, number of years. For example, if you take age, divide into the age groups. For example, if you take into account that impact of age on production also. So we can classify the groups. For example, if you take that young and old, for example, young is nothing but 1, 0 is nothing but old. So we can use such kind of dummy variables as a proxy to the as a independent variables. I think I hope you understood age. For example, if you take into account below 50, for example, if you take working age, above 50 nothing but not working, nothing but old age. For example, if you consider, so you may give 0 for that old, 1 for young, or 1 for below 50 years or working people. So you may classify the age groups and you will give the codes, nothing but dummy variables. So you can run the regression. So that you must see group A below 40, group B 30 to 45, group C above 45. So like this also you can classify the age labels and you will give the codes to the certain public. So for example, when we want to know that saving behavior of the consumers. So if you want to know that with the saving behavior of the consumers, for example, if you take, so how much saving behavior of the below 30 years people and how much saving behavior of between the 30 to 45 years people and what is the saving behavior of the above 45 years people. So you should know that by giving the codes, nothing but proxy variables. And third is, so dummy variables used for that measuring the shift of a function over time. For example, during the shift in the time season, so we can use for the shifting purpose also. So as I told you that from this one, from one normal period to normal period and function, what is it called, festival period. So like this also here, a shift function of a function implies that constant intercept changes in the different periods. For example, as you know that constant intercept changes in the different periods, while other coefficient remains constant. So only other coefficient values, that is a beta 2, beta 3, beta 3 will be changes, but only your constant will be changes. So I will give the example also. Such shift may be taken into account by the introduction of a dummy variable in the function. See, if you have the data on consumption from 1900 to 1968, but in this period there were a war. For example, if you take 1914 to 1918, the First World War, for example. So from 1940 to 1945. Then in 1929 to 1933, there's a Great Depression, I think, in our economics. So in this period, if you want to know that the consumption behavior or consumption levels, so the abnormal conditions prevailing in these years have caused a shift of the consumption functions. So that is a consumption shift, nothing but here during this time and during this time, there is a consumption shift. So how we can write consumption function? See, the CT is equal to beta 0 plus beta 1 yt plus beta 2 d is equal to 0. So here, as you know, the C is nothing but consumption and time, and beta 0 is nothing but constant value, beta 1 yt nothing but income of the slope of the income, plus beta 2 d, that is a dummy. That is called normal period and depression period. We can say that war period or depression period, we can give the codes. So as I put it, D for dummy. As you know that U is the random term, that is the error term. For example, as I discussed just now only in the previous slide, normal condition dummy variable Ct is equal to beta 0 plus beta 1 y plus beta 2 d. So if you take that the normal period is 1, options is 0. For example, I will take, see if you take this one, beta 0 plus beta 1 y1 beta 2 d 1, nothing but d into 1, nothing but see the presence of the variable. And you can say same thing, beta 1 y2 plus beta 2 d1 is equal to d into 1 1 plus u. So if you take Ct is equal to beta 0 plus beta 1 y plus beta 2 into 1 beta 2 only plus error term. So if you take that C here, Ct is equal beta 0 plus beta 2, it will have nothing but, that's why there is a changes in the constant or intercept beta 1 y plus u. And if you take the abnormal conditions, for example, as you know that during the war period, if you take Ct is equal to beta 0 plus beta 1 y plus beta 2 d plus u. So just a minute. See here, Ct is equal to beta 0 plus beta 1 y plus beta 2 d into 0. So when you multiply the d into 0, 0. So when you multiply d to b2 coefficient into 0, 0. So then here see, only Ct is equal to beta 0 plus beta 1 y beta 2 into 0, 0. If you add, no problem. If you don't add, nothing will be happen. So simply you can put plus u. So automatically you will get Ct is equal to beta 1 plus beta 1 y plus u. See, there is a difference. Here we are going to add that slope of the intercept and slope of the dummy variable presence. So as I told you for that beginning also, it is repeated. So these are useful when we have the shifting functions, we can use the dummy variables. So if you put the graph also, see, this is the normal intercept from 0 to here. That is the Ct is equal to beta 1 plus beta 1 y. So as you know that how much income changes, how much changes in consumption. So if income increases by something, how much changes in consumption level. So from here to here, for example, if you take the beta 1, beta 0 plus beta 2, there is a slope, nothing but, so from here to here, this is beta 0. So what are the changes in the dummy variable, in the presence of the variables? So that is the impact, how much income changes, how much can changes in the consumption. That is called beta 0 plus beta 2 here. From year to year is a beta 2 slope. From year to year, beta 0. That is why beta 0 plus beta 2, that is the changes in constant levels. There is a constant values. So from the onwards, there is a no difference thing, but the slope will be same. See, there is a straight line. There is no ups and downs. The two lines. There is a two lines are straight lines. So as you observe in this graph, we can see that the shift in the consumption function during the abnormal. So there is a war and depression here. Then the slope of the consumption function, that is MPC, is assumed to be same. That is MPC should be assumed to be same thing, but the same. The difference between the two curves is same in both normal and abnormal periods. And dummy variables used for the measuring the changes in parameters, change of the parameters, that is the slope of over time. So at the same time, dummy variables can also use for measuring the changes of parameters. So it is known that over the long period of time, that is when you take the number of years more, in abnormal wars years, not only due to the function shift, their constant intercept changes. As I discussed, that constant shift also changes, but also their slopes may well be expected to change. For example, sometimes the slope may be expected to change. For example, here see, so before war and after war, here it seems that there is no shift. But if you take into account during the war, what will happen? There is no income, but you're into do some consumption. I think, but here the change in consumption higher than the change in incomes during the war periods, because no one can produce. Okay, whatever the produce, whatever the produced goods are there, so it will be over during the short period when there is no production. So as you know that due to the corona, most of it. So that the slopes will be expected to change, and elasticities and propensities changes over time. For example, if you take this period, so consumption is nothing but beta 0 plus beta 1 y, beta 2 d1 plus beta 3 d2, dummy variable 1 and dummy variable 2 in the multiple regression. See, for the normal period and abnormal period. For example, if you take du0 nothing but abnormal period, nothing but during the war season, and one is for normal period. For example, due to here see, for war and depression period for normal period. For example, if you take a abnormal normal period, for example, if you take as we know that normal period and abnormal period also we can say nothing but when the situations are normal we can take, if the situations are not good, and when there is a war is there, so what will happen? For example, if you most of the people have seen that when there is some curfews in Kashmir, what will happen? The people may not come to the cannot come out from the home, so simple they need to purchase their needs, nothing but whatever they needs. For example, if you take basic things, so they should have to pay whatever they demand, nothing but if you take for example 100 rupees per kg of onions, they should have to pay because there is no bargain, because with the war season, so whatever they need they need to pay, nothing but here how much the income comes and how much they spend money, nothing but so the changes in income is less than the changes in consumption. So for the peace period, the consumption function would be given. For example, Ct is equal to beta 0 plus beta 2. As we calculated that beta 0 value beta 2, that is we can when we are adding the coefficient, that is from intercept value, and beta 1 plus beta 3. For example, here as we know that it is from beta 0 plus beta 2. As we added here, see beta 0 plus beta 2. Then if you take another dummy variable, it will give the values, that is beta 1 plus beta 3. So here, whatever the beta 1 is there, that is the slope of income, and beta 3, that is the slope of war. So we can add. So here, due to change in income, how much change in, due to change in war also, how much it can impact on the expenditure. That is the expected estimated beta 1 plus estimated beta 3 into y. So for normal years, the function would be like this, the normal years. That will be the estimated beta 0 plus expected estimated beta 1. There is a normal period. As we calculated not generally, we can. And fifth one, the dummy variable used as a proxies for the dependent variable. So this is one of the future main use, dummy variable used as proxies for the dependent variable. So whatever we discuss up to now, up to this one, up to here. So the dummy variable used as an independent dummy variable used as a proxies for the independent variable, but we can also use dummy variable for the dependent variable, proxies as for the dependent variable. So how we can use the dependent variable as a dummy variable? The dependent variable of a function may be a dummy variable. So whatever we write, that is a y is equal c, ct is equal is a, if you take y for example, ct is equal to beta 0 plus beta 1. If consumption is a dummy, we should write that is called if the dummy nothing but the dependent variable is a dummy variable. So how we can take, for example, if the income is affected by, if a gender is affected by income, if you take this a y is equal beta 0 plus beta 1 x1 plus like this. So if y is nothing but gender is affected by income. If it is affected, gender is affected by income, we should take gender is equal to, that is the gender y is equal beta 0 plus beta 1 y. That is the y is nothing but income. Here, sorry, here if you take x is nothing but income, here y is nothing but gender in your regression model. So don't confuse y is nothing but dependent variable. So we should write y and here also x1. So for example, see if we want to know that the determinants of car ownership, for example, see, if you want to study that what are the determinants of car ownership, for example, you want to know that what are the ownership, if you want to know that car ownership, so nothing but if you have the car, what are the factors are determining to have the car? For example, మీకు కారు ఉంది అనుకుంటే సో మీరు ఉందనుకోని గల కారణాలు ఏంటి we can find out. That is called determinants of car ownership from a cross sectional data. Cross sectional data nothing but at a point of time. For example, if you have the car, okay, I can assume that you have the car. So I may ask some questions that relate to the car ownership. For example, how much you are getting income. So what are the characteristics you need? If you, for example, if you don't have the car also, I can ask the questions. Because why did not purchase a car? I can ask the questions. For example, what are the factors are affecting the having the owner of the car? So that is we can take some data from sample. Those who have the car and those who will not have the car also I will collect. So there is a, for example, owner of the car. Car is C is called beta 0 plus beta 1 y plus beta 2 d plus u. So what is C here? Car owner. If you have the car, yes, or non-owner, nothing but. So if you are a car owner, I will put 1. If you are not a car owner, I may take 0. For example, I may ask the question I may ask question to the cab drivers, especially if you can understand easily. For example, see, those who are driving the cabs, so some people they have their own cars, some people they don't have the cars are not their own. So I may ask some question that, so that is C, what is their income? C is nothing but C is equal to car owner or non-owner. Beta 1 nothing but slope of income, and D for dummy. So the profession, for example, if you take if the cab driver they may have the cars, some people they don't have the cars. For example, if I ask you also, for example, you are the student, for example, the student have the car, yes, I can put 1. If you don't have the car, I cannot put the 1 for the cars. So we can take such kind of regression. So here dependent variable, that is a C, will be the dummy variable, which may be assigned the value 1 for a person who owns a car. Those who owns a car, nothing but those who have the car only, I will put 1, nothing but they have the car. And what is their income and what is their profession. So on the basis of profession also, the car may be, they may have. For example, if you take, for example, is a judge, for example, the people they might have car only because on the basis of their profession, they can maintain the cars. For example, if you take softwares. So if you take the profession of the people, for example, if I call information from the software people, so their profession is software engineer. So definitely most of the people they might have the cars. For example, if I have the student may not have the cars. Only less people they have the cars. Am I right? So like this, I can put 1 for the person who owns a car and 0 for a person who does not have the car. So we can say that a dependent variable is a dichotomous. So simple, you can see that dichotomous. Dichotomous nothing but what is a dichotomous? Only 2. So this is a very important question which will come for the net also. So if the dependent variables values is 2, that is called dichotomous. If the dependent variables values are 3, there is a trichotomous. The dependent variables values more than 3 or 4, let's go polychotomous. So in this dichotomous, that is when we have that dependent variable as a qualitative or dummy variable, the functions and the distribution term will be heteroscedastic. Nothing but each and every observation is nothing but error terms have the not same. Nothing but the variance of the error term is not same. So that the method of overlays is not appropriate. And the fifth use of dummy variable. See the dummy variable used for the seasonal adjustment of the time series. For example, as you know the seasonal adjustment, when you have studied the time series analysis in the second semester, I hope, we have the time series components. There is a secular trend, seasonal variation, the cyclical variations, and random variation or irregular variations. So for seasonal adjustment, nothing but when your sales, for
Yes.
example, yes, please. If you take the seasonal sales, for example, if you take thumbs up or some cool drinks, what will happen during the particular season? The sales will be peak levels. During the other season, the sales will be very less. So here, one of the most common application of the dummy variable is removing seasonal variation in the time series. So that's why, so sometimes we will remove some seasonal variations from the data set. So for the example, if you have the quarterly data, for example, see if you have the quarterly data on sales. For example, if you take the thumbs up sales, for example, generally we will get the data on quarterly. Or if you take the GDP also, we'll get some quarterly data. So, for example, if you take the thumbs up sales, for example, during the March to June, the most of the sales will be occur. Nothing but the sales will be happen. So we should adjust for bulk sales purchase at a festivals. For example, if you take the other sales data also, for example, as we discussed that cloths. So during the festivals only, particular season only, so the sales will be high. For example, see if you take the data, time period data, time series data from 1980 to 2010, that is the 30 years data. So if you take the quarterly data, there is a quarter one, quarter two, quarter three. So from 1980 to 1990, there is a quarter one. So 1991, 92, 2000, quarter two. So for example, if you take this kind of quarters data, so what you can write an equation that is a y is equal beta 0 plus beta 1 d1 plus beta 2 d2, beta 3 d3 plus u. So during the first particular years, you should have to take dummy variables. What is the presence and absence? So as you know that, see, d1 remains dummy variable. Nothing but d1 is nothing but data. D1 is nothing but d1 is equal 1 is nothing but presence of the season. If d0 is nothing but absence of the season. So for example, d2, about d2, what d2 is there? D2 is 0 and d1 is 0. See, d3 is equal 0, d3 is equal 0, d3 is equal 1. So like this, you will get it. So for example, here d1 0, d2 0, d1 1, d2 0, d3 0, d3 1. I hope here it should be 1. Okay. So for the data dummy 2, 1 and 0, d3 0 and 1. You should take like this dummy variables. So have you understood what are the use of dummy variables? Hello?
హలో సార్
అర్థమైందా అమ్మా?
అర్థమవుతుంది సార్.
So this is the last one. I would like to say that measurement of dummy variables, how we can measure the dummy variables. See, when we use the dummy variable that is 0 and 1, it is called dichotomous. As I told you that just now only, when you use 0 and 1 or 1 0, there is a dichotomous. For example, when we use the dummy variable 0 1 1, nothing but absence, presence and presence, it is called trichotomous. When you use the three dummies, that is a trichotomous. So when we use the dummies like this 0 1 1 1 1, that is called polychotomous. Nothing but when you use more than three variables, three dummies, that is called polychotomous. Please remember that this is very important. This kind of question will ask in the set and net also. If you have the two dummies, that is a 0 and 1, what it calls dichotomous, trichotomous, polychotomous, or none of the above. So when we have the three dummies such as 0 1 1 1 1 or 1 0 1 also. So don't confuse. Here it may be 1 0 0 or 1 0 1. Okay, that is called trichotomous. So there are three methods to measure the dummy variables. So when we have the dummy variables as a dependent variable, we have the three methods such as the linear probability model LPM and logit probability model, and probit model. So we have the three models when the dependent variable is a dummy variable. When the dependent variable is the dummy variable, we have the three models to use or to measure the dummies. This is a linear probability model, logit model, and probit model. So I hope you understood up to now. And hello.
Yeah, sir.
So see, tomorrow we will discuss about the what is the stability regression and what is logit. We don't have the probit model. So if the time permits, I will teach you that what is the probit model, how we can estimate the probit model also, And after that, how we can estimate and what is the concept of this logit model, and how we can estimate the values of the coefficients by using the logic model, I will explain tomorrow. So I hope you understood, or if you don't have understood also, you can refer the book. That's a Gujarati book, as I told you that. So anything is left, Kamatam?